Do you want to learn to write Python programs that can communicate with each other over the network? It's easier than you think using sockets in Python. In this video, we're going to take a look at it from a beginner's perspective so you can take your code to the next level. Stay tuned. All right. Hello, everyone. We're going to get started here on a new program. In fact, this is going to be actually a couple of different programs, two of them. They're going to use a concept called sockets to communicate with each other, not necessarily directly with each other in a centralized location, but to allow it to communicate with any other file, a program that you set up as a server or a client on any other device, as long as you have the appropriate IP address and ports that it's using. So to get started, we're going to create two different files, a server.py and a client.py. The server is going to be our application that's going to host our connection, and then the client will be our the code that will go ahead and establish a connection to it and interact with the server. If you use any web pages before, I'm sure most people you're searching now on a web-based platform. You're familiar with using a client-server model to reach out and get the data you're looking for. Typically, when you're talking about web pages, it's all served on port 80 on a specific website address. But it doesn't necessarily need to do that. You can technically use whatever IP address your server is hosted on, and then use a specific port that your server is set to listen to, and you can send any type of data back and forth. It's just port 80 for HTTP traffic, web traffic is typically the most common use. So to get started, it's actually one of the standard library packages. So all you do is you import socket, and then you need to set up a couple things to establish the connection for the server. So you need to set it up as a variable. So common nomenclature is just use S for the socket and set it up as socket.socket. And then there's a couple different parameters that can be sent. Address family is one of the required ones. And there's a couple built-in variables that you can use, for lack of a better word. So if you use socket.af_inet, so this is just a shorthand notation for something that's already set in as kind of a constant. And this is basically indicating that we're using basically IP version 4 formatting. The other piece we need is a socket. If we, it's looking at our socket kind, and that's your stuff like TCP or UDP. Again, if you're not familiar with that, I encourage you to do some research on the different network protocols. But if we're going to try to use TCP, which is one of the most common, then I'm going to use socket.sock_stream. And then the next thing we need to do is have our server bind to a specific port. So basically, what address and what port are we going to listen to for communication? Now, in this case, both of these programs are running locally, and there's a special IP address for local communication, and that's 127.0.0.1. That's your local host, your loopback. So we'll use that in this case, but it doesn't necessarily have to use that. You can substitute any IP address in that case. So we'll say s.bind, because S is our socket instance, and it takes a tuple. So that includes a string of the address, and then it also needs comma, the port we're going to listen to. So there's common ports. You can use 80, you can use 8080, but those are typically used for existing applications. So you can pick any port you want, really. So let's pick 5555. Now, an interesting thing here, another way to make this easier, because it is kind of hard to see, there's two parentheses here. You can set something as server and let that server basically equal this tuple, basically this value contained within parentheses. You just pass in server into the same concept. And then we'll take a break from the server for a second and let's look over at the client. So a lot of it is going to be similar. We'll do socket. And we start kind of the same way. It's going to be using the same protocols here, IP version 4 and socket stream. So let me just actually copy that over. And then we need to tell it what exactly we want this client to connect to. So you use s.connect. And again, we'll do 127. Actually, it's a tuple as well, so we need it inside parentheses. So we can do the same thing we had here with setting up a server, or we can paste it in there directly. I'll paste it in directly just to show that both methods work. The key thing is that it needs to, exactly match the IP address and the port being used for the server. Okay, so basically those are set up, but right now they're not really doing anything. If we run them, it'll work, but there's not really anything that it's doing. So going back to the server, we also need to tell the server to listen for connections. And you can tell it, how many it'll listen for up to. After that, it'll ignore any other incoming requests. And then in previous videos, we looked a little bit at some loops, how to keep things going for a specific amount of time or specific instances. But we can do something here like while true, and basically it'll allow this part of the code, once the server has been established, to run forever. And what we do is we say client, and we can call it anything because it's really a variable. So essentially, we're calling this socket instances its accept method. And what that does is if there's an incoming request, it'll store the information for that request, the client socket, and the address that it's coming from in two variables. So this goes back into one of the previous videos where you can have multiple return items from a single method. And then just to validate that it's working, we can just do print connection from, then we're going to take the address that came in and convert it to a string so we can format it here. And then okay, and now on the client side, we need to be able to create our connection. So in order to do that, we're going to use on our client. So we've already connected. And, there's typically a problem if you just leave the connection open. So we're just going to do s.close for now. And down here in the terminal, I have two of them created. And one's going to run server and one's going to run the Python or the client. So first I'll run the server. And you can see it's still kind of hanging there. That's because we're stuck in that while loop. And then our second one, so that one went through right away. But if we look at our other one, we see that we had a connection established from, again, locally, and then it's just picking whatever port was used to connect on the client side. And then it's still in that loop waiting for more connections, but the client closed at that point. So if we run the client again, we'll see we get another established connection. You see it used a different port this time as well. So coming from the client, the port itself doesn't matter for the connection. It's just using whatever is available. Okay, so now let's do something a little bit more useful. So one thing you can do is, let's say we want it to start on the server side, the communication. And once the connection is established, what we're going to do is we're going to send a message to the client saying it's been established. So to send out a message to the client, we use our variable. We do .send. And the thing with network communication using sockets, it all has to be sent as bytes. So you can create, put a B in front of the string, and it'll say send the byte version of this message. Or you could do something like message as a string and then encode it. So I'll do that one a little bit later in one of the other examples. Now on the client side, what we need to do is, before we close our connection, we're going to do s.recv for receive. And you tell it how many bytes it's expecting. So in this case, I'm just going to put 100 for now, but we'll get into some details for how to fine tune that. And then we're going to get something back from that. So we're going to save that into a variable and just call it response. And then we can do print. So what's happening here, we're getting a response back, and the response is in bytes because that's being sent over the communication. We're then taking that response and decoding it into UTF-8 format and printing it. Now, if we run these servers again, this server is already running, so I'm going to do a Control-C to stop it. My computer's lagging a second. I'll just kill it manually. All right, so now if I run the server, so it's running there. And now if I do the client, you can see we actually got connection established. So connection established didn't come anywhere from the client side. It actually was a message sent from the server itself. So that's all interesting, but what else can we do with it? So we can send messages back and forth from the client as well. So let's say after we've got this message that we've been established, we're going to send a message from the client back to the server. And, typically you won't print out something on the server side because nobody's actively monitoring it, but it could be something that maybe it's an option that you send. And based off what you send, the server will send you something back. So in this case, we're going to send from the client side. We're going to do s.send, and let's just send Actually, we could do the same way we did before, so putting a B in front of the string, but we'll say something like that. And then we'll do, so you can do something like message equals message.encode, or you can just pass in message.encode. In this case, we're just updating it to be message equals message.encode for the same value. And now we're going to do s.send our message. And on our server side, so after we've sent this message, we do the same thing on this side. Client sock.receive. And let's say we're expecting 100 again. And we're going to save it into a variable. And just like we did before, we can do print my message.decode. And let's try this again. So if we look back at our server, we see that we also got tests from the client side. Now, one thing I want to make important that you understand here is these buffers that come through. So when we're passing in these integers, it's saying how many bytes we want to try to receive. If it's not enough, you get some interesting behavior. So let me say it's just 5 here. And then after we've sent connection established, let's say we want to just send goodbye. All right, so we have that. And now we need to do another receive. And we'll just do this same code we have here. We'll receive 5 bytes. So you would expect from the server, since this was cut off, you would expect, okay, well, it's going to send in the next 5 bytes of goodbye. But because it's still in the buffer, you get some unanticipated behavior. So instead of getting the full message of connection established, it takes the first 5 bytes. And then once we get to this point, when we're sending the values and expecting to receive it, it's just picking the next 5 bytes for connection. So as you can see, it's not necessarily what we expected. We expected to see some goodbye there. But if we bump it up to well more than what we're expecting, and you see it also forcibly closed the connection here because it didn't know exactly how to handle that. So let me start the server again and run the client. Now we see it working properly because the buffer is big enough. But that's not always the case. You don't always necessarily know how big of a buffer to use. So that's where some proper planning and some protocol comes in of if you have a specific client server application where you know the sequence of events that should be sent, you can hard code those values. Otherwise, what you can do is you can gather some information ahead of time. So let's say there's a file you want to get from the server. We'll just call it myfile.html. txt. And inside of here, we'll just put in a bunch of garbage. Doesn't really matter what's in here. So on the server side, what we're going to do is we're going to go in and import the OS library. And while we're doing all this, we're going to grab the file size of that file. So this will capture the size in bytes of this file name. So right now, we don't necessarily know how big it is, and they could change over time. So what we can do now is instead of just sending connection established or goodbye, let's just replace this goodbye with actually the file. So what we're going to do is we'll use our file nomenclature here, f equals open. We're going to get the file name. And we'll save the content of the file. So again, here we're opening the file, and then RB means read it and read the bytes specifically. We'll close the file that we're reading. And then what we're going to do is we're going to use that client socket .send, and we're going to send the content. Now, because we read it as bytes, it's already in bytes format, so we don't need to encode it. And on the client side, so we're going to need to have another message here before we send this. And we're going to actually send the size. So we'll have client socket .send. Now the file size is an integer, so we need to convert that integer to a byte. So there's a couple ways we can do that. How we're going to do it here is we're going to convert it to a string first, and then encode that. And then we're going to send, so we're sending that. And on the client side, so this is happening after they sent this message, we're receiving our bytes. So we know this response at this time. This is where you come into a protocol of understanding that this will be the next thing to come. So the client will be built to say, we'll call it size there, my size equals response dot, actually it's int in response. So we know at this time, if everything is running properly, this response coming back will be an integer. And now with that, what we can do is get another receive using my size, and we'll open a new file. And since we're receiving bytes, we can actually write it as bytes as well. We're just going to write the content that we just got from our server. And of course, we'll close. All right, and now we don't necessarily need this anymore. Let's see what we got here now. Let me kill this. All right, so let's start our server. So we see we have new file.txt, and it's the same thing as my file. Just moved over slightly. And we didn't just make a copy of this here. We actually sent the bytes of the file from the client, or from the server to the client, and the client made a local copy. So if we use this on another device, you can actually move the files back and forth that way. So it's any type of files, any type of data, just needs to be bytes. Again, this is just scratching the surface of what you can do with sockets in Python. If you want to see more on this, just reach out and let me know. Maybe in the future I can do a more complex intermediate level video. But this is basically the basic concepts of using sockets in Python. So for now, that's all I got.
Good news, everyone.
That's right. Good news, everyone. This is Doc here. You made it to the end of the video, which means you liked it. So please click on the thumbs up below the video. If you have any comments, anything else you'd like me to see put a video together for, leave a comment, ask any questions. And of course, more videos like this are coming, so be sure to subscribe.